We are group 8 for the chemistry final project. We decided to choose chapter 4, and in this presentation we're going to discuss information in detail and orally of what chapter 4 describes. Elements are substances from which all things are built. Aluminum, gold, cobalt, carbon, calcium, copper are all examples of elements. And each element has a chemical symbol, and chemical symbols are abbreviations for the elements. An element can either have a capital, just one letter abbreviation, and they can have a capital with lowercase abbreviation if they don't have the other version. With elements, they started being discovered rapidly, and scientists decided to organize the new findings into a chart, and the chart was organized by increasing atomic mass, and that's known as a periodic table of elements. And as of today, there are 118 known elements on the chart. The chart can be divided into groups and periods. Groups running down vertically, there are 8 groups, and there are 8 groups that are known as the representative elements and the transitional elements. And the representative elements, some of them have characteristics and special features and have specific names. The alkali metals are group 1A. They are shiny metals that are good conductors of heat and electricity and have relatively low melting points. The alkaline earth metals are found in group 2A, and they are shiny metals, but they're not very reactive. Halogens are found in group 7A, and they are highly reactive and form compounds with most yellow elements. And all the way to the right of the periodic table of elements are the noble gases, and they're found in group 8A, and they are quite unreactive and don't combine well with the other elements. And groups 3A through 7A are known as the no common names on the periodic table of elements. So elements are either metals or non-metals. They're in those 2 categories. Metals are shiny, solid, good conductors of heat and electricity. They melt at high temperatures, and they're solid at room temperature. And non-metals, their characteristics are shiny, ductile, malleable, poor conductors of heat and electricity, and they have low melting points and low densities. All elements are made up of atoms, and atoms are essentially the smallest particle of an element that retains the characteristics of the element. Atoms have positive and negative particles, which are called protons and electrons. And the neutron is essentially the central core of an atom. And the neutron holds protons and neutrons and contains nearly all of its masses. So essentially, elements are building blocks of life itself and are essential to chapter 4.
The atomic number of an element is equal to the number of protons in every atom of the element. The atomic number equals the number of protons. The numbers of protons plus the number of neutrons equals the mass number. Mass number subtract the numbers of protons equals the number of neutrons in a nucleus. Atomic mass is the average atoms. To calculate atomic mass, we need to know the percentage abundance and the mass of each isotope. Isotopes are atoms of the same element that have the same atomic number but different numbers of neutrons. To distinguish between the different isotopes of each element, we write the atomic symbol for a particular isotope that indicates the mass number in the upper left corner and the atomic number in the lower left corner.
Electron energy levels. Electromagnetic radiation consists of energy particles that move as waves of energy. High energy radiation has short wavelength compared to low energy radiation, which has longer wavelength. All electrons with the same energy are grouped in the same energy level. An electron dot symbol represents the valence electron as dots that are placed on the sides, top, and bottom of the symbol for the element. The size of the atom is determined by the distance of the valence electrons from the nucleus.